We are going to look at solving some logarithmic equations. There are three basic situations that happen with logarithmic equations, and we're going to look at each one. The first situation that we encounter is one like this. I have log base 6 of 2x plus 4 equals 2. So I have a logarithm on the left and a constant on the right. When that happens, we are going to rewrite the logarithm in exponential form. So remember that if you have log base b of x equals y, in exponential form that is b to the y equals x. I remember it because it kind of makes a little circle here. Goes in a little loop pretty nicely. So if we use that for this problem, this becomes 6 squared is 2x plus 4. So now I'm just solving that equation. 36 is 2x plus 4. So 2x is 32 and x is 16. So let's look at a different situation. The log of x plus the log of x minus 21 equals 2. So in this situation, we have a combination of logarithms on the left-hand side and a constant on the right. Before we deal with that, we want to look at the domain, because remember, we cannot take the log of a negative number. So for this first guy here, I need x to be greater than 0. For the x minus 21, I need x minus 21 to be greater than 0, which means x has to be greater than a positive 21. Any answer value I get has to fit into both of those. So now let's go back looking at our situation. I have a combination of logs on the left and a constant on the right. In this situation, the first thing that we want to do is combine the logarithms on the left-hand side. So I can put these together. Remember, when I have the expanded form here of logarithms separated by a plus sign, I can combine it into a single logarithm using multiplication. So that will give me the log of x times x minus 21 equals 2. Now notice I'm in the exact same situation I was in this first problem, where I have a logarithm on the left and a constant on the right. And so we're going to do the same thing we did for that. We're going to rewrite this logarithm in exponential form. First, we need to remember that if we have the log, the common log without a base, we understand that it is base 10. So 10 squared is x times x minus 21. So 100 is x squared minus 21x. So x squared minus 21x minus 100 is 0. We'll factor this. It factors to x minus 25 times x plus 4 is 0. So x is either a positive 25 or a negative 4. So I want to go back to my domain here. X has to be greater than 0 and greater than 21. So the 25 works, but the negative 4 does not. So my answer to this equation is x equals 25. Let's look at one more. Log base 7 of 4x minus log base 7 of x plus 3 equals log base 7 of x. So this problem is different than the others in that here we have an expression of logs on the left and a single logarithm on the right. So the first thing that we're going to do is we're going to combine these two logarithms on the left into a single logarithm. And remember that when you have logarithms separated by a subtraction sign, you can combine them into a single logarithm using division. So I will have log base 7 of 4x divided by x plus 3 equals log base 7 of x. Before we go further, we should have done this at the beginning. We need to look at our domain again. So remember, you cannot take the log of a negative number. So I need 4x to be greater than 0, which means x has to be greater than 0. And I need x plus 3 to be greater than 0. So I need x to be greater than negative 3. So any x value I come up with has to fit both of those situations. Okay, so now we're ready to solve. And just like in exponential equations, if the bases are the same, you can ignore the bases and concentrate on solving the equation created by the exponents. If your logarithms are the same here, as long as you have single logarithms with the same base, you can ignore them and just solve the resulting equation. So the equation we're solving is 4x over x plus 3 equals x. So cross multiplying will give me 4x is x squared plus 3x. Moving the 4x to the right-hand side will give me x squared minus x equals 0. Factoring out an x will give me x times x minus 1 equals 0. So x is either 0 or 1. And then I need to go back over here and see that both of those numbers fit the issues here, and the 0 does not work. You can type log 0 into your calculator and you will get an error. And 1 is greater than negative 3 and greater than 0, so the 1 works. I hope this gives you a little bit of extra confidence on logarithmic equations.